Today's notes are going to finish out chapter 4, and this is 4.7, transformations of quadratic graphs. And what you're going to notice is we're going to be looking at the vertex form of quadratic functions today. And that is this form right here. And here's what you need to know about this form. HK is the vertex. And I just want to point this out to you. Notice that that is a minus sign. So the form always has a minus sign. It would only become a plus sign if it was like this. If the H was a negative, then this would obviously become a plus sign in here. Also, the x equals h is our axis of symmetry, and then A is going to determine which direction that the parabola is going to open. And so just as a reminder, if A is greater than 0, then the parabola is going to open up. And if A is less than 0, the parabola is going to open down. The last thing to know is we're going to be doing what's called completing the square. So when you have a quadratic that is in, this is, remember, standard form right there. If we want to put it in vertex form, then we're going to do this right here. We're going to complete the square. And so to complete the square, what you're going to do, we'll just write this above it, is you're going to do b over 2, and then you're going to square that. And then you'll see how this works as we go further. So let's scroll down and look at this example here. Why can I not scroll? Okay, here we go. Okay, so let's look at this first one, A. So let me erase all of this. Okay, so this function is in vertex form, and so we are going to put it in standard form, or I'm sorry, it's in standard form, and we need to put it in vertex form. And so to do that, we're going to complete the square. So my b value, I'm just going to write this here, is 6. Okay, so what I'm going to do is I'm going to rewrite my function. So I have this y equals x squared plus 6x plus, and then I'm going to leave a space because that's where I'm going to put this new constant that I'm going to add to it. Then I'm going to bring down this minus 5 that was there, and then I'm going to leave another space because I need to keep this equation equal. And so when I complete the square, I'm doing this b over 2 squared, and my b is 6. So 6 over 2 is 3, and when I square it, I get out a 9. And so what I'm going to do is I'm going to put a plus 9 here, and to keep it balanced, I'm going to take off that 9 here. So whatever I'm adding to, I'm going to subtract away, and whatever I would subtract, I'm going to add. And then what I'm doing is I'm looking at just this portion right here, and I want to write that in factored form. So if you look at this, I'm looking for 2 factors of 9 that are the exact same. This is going to work every time. And that would be 3. And then 2 that are the same to multiply to give me x squared is just x and x. So when I write this in factored form, that would be x plus 3 times x plus 3, which is the same thing as x plus 3 squared. And then I'm going to combine my constants, and that's minus 14. Okay, so that is completing the square. So the whole idea is that whatever I have right here in this trinomial should be able to be factored where 2 numbers that are the same, so this is a perfect square right here, 2 numbers that are the same multiply to give me that number, And then the same thing in front, two numbers that are the same multiplied to give me this. Okay? And the other thing we're going to do, I didn't put this in the directions, but let's just write it here. I also want you to identify the vertex and the axis of symmetry. And I'm just going to write A of S. So in this case, my vertex, and I'm just going to label it with V, would be -3. So remember what we talked about earlier, the normal formula has a minus sign right there. To make it a plus, that must have been a -3 plugged in. So -3, comma, -14. The y value is always exactly what you see back here. And then the axis of symmetry, remember that's a line. And so that is a vertical line, so it's x equals, and in this case, -3. It's just the x value of your vertex. So I have my answer in vertex form with my vertex and my axis of symmetry. Okay? So let's try the next one. So this one, my b is -4. Okay? So when I do this b over 2 and I square it, I'm going to have -4 over 2, which is -2, right? Write that. -2 and -2 squared is 4. So when I complete the square of this, I'm going to write y equals x squared minus 4x. Remember, I'm leaving a blank there, and then I'm writing this plus 6, and then I'm leaving another blank, and that's where I'm putting what I got when I completed the square. And so what I got when I completed that square was a plus 4, and so to keep it balanced, I need to take off that 4, okay? So then, recall, I'm just looking at this trinomial when I write this in vertex form. So I'm looking for two numbers that are the same that give me 4. There's my 2. And then 2 that are the same that give me x squared is my x. And then this time, I need this to be a -4x, so this has to be a negative inside here. And then I put my squared. And then my constant, plus 6 minus 4 is a plus 2. So then when I write my vertex, my x coordinate is just 2 because the formula in vertex form always has a minus sign. So I know my x coordinate is just 2. And then my y coordinate is positive 2. And my axis of symmetry, remember, is just x equals whatever the x value is of your vertex, which would be 2. And so that is how we take something in standard form and put it in vertex form. Let's try the next example. So let's look at C. So let me erase. Okay, so for C, let's write down what our B is. So our B value is positive 8. Our B is positive 8. And so when oh, sorry, I did something wrong here. So let me show you this. Let me erase that. So what I need to do here is I cannot have anything but a coefficient of 1 in front when I do completing the square. Okay, so let me show you what you're going to do. So I'm going to write y equals, and all I'm doing when I do this, so remember, this constant at the end right here doesn't play a part in our completing the square. So I'm just looking at these two terms right now. And so what I want to do is I want to get that a to become a positive 1. So I'm going to take out a -2. And that's going to leave me x squared and then a minus 4x. Okay? And then I'm going to have this blank, because once I complete the square, I'm going to add something to that. And then I have my -3, and then I have this blank because whatever I add, I need to subtract off. to keep it balanced. And then I have y equals. So if you're looking now, I have to look at, I can only look at these two terms because I can only complete the square when my a is 1. So my b value is -4. So my b is -4. So when I complete the square, that's -4 over 2 squared, which is 4. So I'm going to add 4 here. And then here's the key, what you have to pay attention to. Remember, I took something out. So I really added -8. That's really a -8. So to cancel that, I need to put a +8 there. So if you have to take out the leading coefficient, you got to make sure you think through, multiply it through, and see what did I really have to take out, or what really did I add to the equation so that I can balance it then over here. Okay? So now once again, I'm looking at the trinomial. So when I look at this and I do this trinomial, I'm looking for, once again, two numbers that are the same. It's always going to be this, to give me a 4, and then two that are the same. Hopefully you're noticing a pattern. And then that's a -4x right there, so this has to be a negative. And then I square it. Bring down your a, which is -2, and your y, and then when I combine my constants, that's a +5. So there's my equation in vertex form. My vertex would be 2, comma, remember the negative is always there, so it's just the x-coordinate is 2, and the y-coordinate would be 5. And my axis of symmetry would be x equals, and that's the x value of my vertex, which is 2. And there would be my answers. Okay? Just a good thing to note, and I didn't ask you to do this, but to be able to look at this in vertex form and know whether it opens up or down. So remember, you're looking at your a value. So this one would open down because my a is negative. And it's just good to recall that. Okay, so let's try another one like this. So once again, I'm going to start off and I'm just looking at my first two terms right now because they're the only two I'm dealing with when I need to complete the square. And what I notice is that I can take out a 2 and I need to take it out because I need my a to be +1. So I have x squared minus 6x. I'm going to leave a spot. And then I have plus 17. And then I'm going to leave a spot to keep it balanced. And then I need to write my y equals here. Okay, so remember that you're looking here at your b value. So my b is -6. So I'm going to do that over here. I'm doing -6 over 2 squared. -6 over 2 is -3. When I square it, it's a +9. So I'm putting +9 here. Now remember, we took out a 2. So when you think about what you really added to this expression, you really added a +18. So to counter that, I need to subtract 18. Okay, and then we're looking at our trinomial, and we're writing it in factored form. So x will be at the beginning. Two numbers that are the same that multiply to give me 9 are a 3. This is a -6x, so that's going to be a negative, and then I have squared. Bring down my 2, which is my a. Bring down my y equals, and then when I combine my constants, that's a -1. So the vertex would be the 0.3, comma, -1. Remember, your y value is always the sign that you see. And the axis of symmetry would be x equals 3. And this one, if you look at the vertex form, my a is positive, and so this one would open up. And again, I didn't ask you to write that, so you don't have to do that. okay? So let's move down to E. Let me get a little more room here. Okay, so on E, notice that my A is not +1, it's actually -1, so we need to deal with that. So again, I'm only looking at my first two terms. Nothing else matters when I'm completing the square. So I'm going to take out a -1, and that will give me x squared and then minus 8x. And then I know I gotta leave a spot open, and then I bring down +12, and then I need to leave a spot open. And then I need to bring down my y equals. Okay, so when we complete the square, notice I'm looking here, right, at my new b value. My b is -8. So when I complete the square, I'm doing -8/2, which is -4. And when I square it, that's a +16. So I am adding 16 inside there. Recall, I really added, because I got to take into consideration the -1 I took out, I really added -16. And so I need to counter that by adding 16 to the end. Okay? And then we are going to write it in factored form. X will be in the front. Two that are the same that give me 16 is 4. This is a negative, so I know this has to be negative, and then I'm going to square, bring down -1, bring down my equals and my y, combine my constants, and I get +28. My vertex would be 4, 28, and my axis of symmetry would be x equals 4. And if I asked you, does this open up or down? I hope you're getting the hang of this. This opens down because my a value was -1, and so it's negative. Okay, last one we're going to do like this. And I was going to have you do this one on your own, but I'm going to do it with you since you're going to end up with a fraction on this one. So again, I only care about my first two terms. In this case, my c doesn't exist, which is fine. I have to get my a to become +1. Up to this point, the common factor that we've taken out has been a common factor, like over here in both terms, like -1 was in both terms. So this time, when you take out a 3, you're going to have a fraction left. So this becomes 7/3x. And then we have to figure out, let me get a little more room here. Let me try that again. So I'm taking out a 3. So that becomes a fraction. And then we have to figure out what are we going to add on to that. And then I need to balance it and take it off in the end. Okay, so I need to do completing the square. So my b value is this 7/3. So I'm doing 7/3 divided by 2. You can do that on your calculator, or it's the same thing as taking 7/3 times a half, which would give us 7/6. And when I square that, I square the top, and I get 49, and I square the bottom, and I get 36. So I'm going to be adding 49/36, and then remember, I took out that 3 there. So when you multiply 3 times 49/36, you get 49/12. And so we need to subtract 49/12. If you aren't good with fractions, use your calculator. Remember that this button on your calculator will put it into a fraction. So you would do 7, this button, and then 3, and then divided by 2. Equals, and then square it. Okay, so now we're going to put this in factored form, and you don't need to freak out. Once again, x is in the front. And then what two numbers that are the same give me 49 over 36? 49 and 36 are both perfect squares. 7 over 6. So I have 7 over 6. And then this is positive, so that's a plus. Put my squared, and then I'm just going to bring everything down. 3y, and I just bring down 49 over 12. My vertex, I don't know why my 12 isn't writing. There it is. My vertex would be a negative 7 over 6 because that formula has a plus sign. So remember, to make it a plus, had to be a negative that was plugged in, comma, negative 49 over 12. The axis of symmetry would be x equals negative 7 over 6. And this one would open up because my 3, which is my a value, was positive. Okay? All right, let's turn the page. And this time, I'm asking you, looking at a graph, can you tell me what the equation of the function would be? And so I'm going to show you, I know this is multiple choice, I'm going to show you how you could actually do this. So the key here is they've given us the vertex. They've also given us another point on the parabola. So if you go back to vertex form, if you know the vertex, then you can put something in vertex form. And this is vertex form, remember? And so when I do this, I can do my vertex. So my H is right here, my x coordinate, which is 3. And then my y value of my vertex is 2. Okay? So I have that much done, but I also have this point. And this is the x value of my point, and this is the y value. So I can plug those in. So instead of y, I have negative 2 equals a, and instead of x, I can plug in negative 1. And then we can actually solve this for a. So to solve this, I would do negative 1 minus 3, which would be a negative 4a, plus 2 equals negative 2. I'm going to subtract 2 over, and then I'm going to divide by, oh goodness, I didn't do something right. What did I mess up on? Do you see my mistake? I see it. Forgot to bring down this squared right here. That's important. So when I do that, negative 1 minus 3 is negative 4, but when you square it, that's actually going to be a 16 right there, not a negative 4. And so let me take it off here, put my 16. And so when I divide by 16, a is equal to negative 1/4. So I know my answer has to be this one. And that also makes sense because our vertex was 3, 2, and there it's located. And my a is negative 1/4. Okay? Okay. The very last thing is just knowing transformations of your graphs. And what I want to point out to you, which we've already done some of these transformations, so I think this will make sense to you. But if you see inside your parentheses, and we did this with absolute value, if it was like inside the brackets, this is a horizontal translation. So H is a horizontal translation, and it's opposite of what you see. So again, this is showing you here, if H is positive, you're going to go, well, it actually works kind of opposite. So let me just show you like this. If it was x minus 3, that actually means go right 3. So it's kind of opposite of what you see in the parentheses, I guess. If it was x plus 3, you would actually go left 3. And I think you probably remember doing that when we did absolute value with the v. This k on the end of your vertex form is going to be your vertical translation. And you will translate it just like you see it. So if k is positive, you're going to go that many units up. If k is negative, you're going to go that many units down. Okay? And then the last part of the transformation, if a is negative, then you would, we already know this, the graph would go down. If a is positive, the graph's going to go up. And then lastly, this over here, depending on how big a is going to mean if it stretches vertically or if it compresses vertically. So if a is bigger than 1, you're going to stretch it vertically, so it's going to become more narrow. If a is between 0 and 1, you're going to compress it vertically, so it's going to become wider. Okay, so just one example of that on the very last page of your notes is being able to take this equation in vertex form and graph it. And so what I want us to do is just write down the translations that we know are here. So the translations are, I know that from the parent function, we're going to go right 3. We're going to go down 2. We're going to go right 3 and down 2. And then in this case, I'm just going to write this to help us. My a is 1. Okay, so right here in front is just a 1. So I know I'm going to open up. And so let's just look and see what this looks like. So I'm going to go to the right 3 and down 2. And that's going to be my vertex. Which also makes sense because I can find the vertex when it's in vertex form because here's my h and here's my k. So 3, negative 2, which is exactly where I'm at. I'm going to go ahead and draw my axis of symmetry through that point. And then since my a is 1, I know I'm just going up 1 and over 1, up 1 and over 1. Why did that not keep my axis of symmetry? Try again. There we go. Okay. Draw that in. And then if you wanted to figure out, what it was at x equals 1, you can just on your calculator plug in when x is 1 and see what you get out. And you should get out 2. So my other point would be 1, 2, and then I'm going to make it symmetrical on the other side. And there is my parabola. Okay? Okay. So now is your homework assignment, and this is actually not correct. So let me give you the correct assignment. You're going to do 2 through 28 evens, and then 36 through 40 evens, and then 51. And one thing I want to make sure we do on 8 through 18, I also want you to write the vertex and the axis of symmetry in your answers. So list the vertex and the axis of symmetry. So as always, if you have any questions, please don't hesitate to message me. Send me pictures of your work if you're stuck. I'm happy to help however I can. Have a great day.